which is a very simple example. So the circuit is given and you are asked to find the current and power absorbed by the circuit. Now we know that power is equal to voltage multiplied by current. Why am I not writing cosine of theta? Because we have a resistive circuit, and the other thing is that we have a DC source. If we have either a resistive circuit or if we have a DC source, then we are going to use this formula for power. We are going to not write cosine theta with it, because then cosine theta will be equal to 1. But in this case we have both, so we have used this formula, power is equal to VI. Now the voltage is known but the current is unknown. To find the current, we know that we are going to use the Ohm's law, V is equal to IR. So I will be equal to V divided by R, which means 12 divided by 2 kilo ohm, which comes out to be 6 milliampere. So now the current has been found out and we can put it in this formula. Power will be equal to 12 multiplied by 6 milliampere, which comes out to be 0.072 watt, because the unit of power is watt. You can also find power by using P is equal to I square R. I is your this thing and R is your 2 kilo ohm. And you can also find the power using V square divided by R. All will give you the same answer, which is 0.072 watt. We are given the power absorbed by the resistor, we are given the resistor, and we are asked to find the voltage and current. Now we know that power is also equal to V square divided by R, which means that V square is equal to P multiplied by R, which means that V is equal to P multiplied by R under root. So the P is 3.6 milliwatt. So that will be multiplied by the 10 kilo ohm. And we are going to then take the under root. So this is going to come out to be 6 volt. Now to find current, again we can use the Ohm's law, that I is equal to V divided by R. And because 6 divided by the 10 kilo ohm, this is going to give me 0.6 milliampere. So we can use Ohm's law to find the current. So the current in the circuit is 0.6 milliampere and the voltage, this voltage source Vs is 6 volt. Now in this example we need to find the equivalent circuit, equivalent resistance between A and B. Now we know that for the series combination of resistors, the resistors are added. For example, I have two resistors R1 and R2, and if they are in series, they are going to be added. For parallel, I need to multiply and then I need to divide by the sum of those two resistors. So now to find equivalent resistance between A and B, we are going to start from the opposite side, that is from this side. Now you can straight away see that the 8 kilo ohm resistor is in series with the 4 kilo ohm resistor. So this 8 kilo ohm and 4 kilo ohm resistors are in series, and when I add them I get 12 kilo ohm resistor, and that's exactly what I have done over here. You can have a look. I have written all those resistors as it is, and in place of this 4 kilo ohm and 8 kilo ohm resistor I have put 12 kilo ohm resistor, because these both are in series. So 4 plus 8 is 12 kilo ohm resistor. So now I have this circuit now. Now again, if you see this 12 kilo ohm resistor and this 12 kilo ohm resistor, they are parallel. Now why are they parallel? Because on one side they are connected to this node, on the other side both these resistors are connected to this node. In parallel, usually one of the resistors, this is the parallel combination. If you can see over here, R1 and R2, on one side they are connected to this node, on the other side they are connected to this node. So they have same node on both the ends. Here again they have same node on both the ends. So this 12 kilo ohm resistor and this 12 kilo ohm resistors are in parallel, and for parallel the equivalent resistance will be the multiplication of both divided by the summation of both. So 12 multiplied by 12 is 144, and that is going to be divided by the 24, which comes out to be 6 kilo ohm, that is. So now I can replace these two resistors by 6 kilo ohm resistor. So I'm going to do it now. I'm going to erase this. Now I'm going to okay. So this will be now your 6 kilo ohm resistor. Fine, because the two 12 kilo ohm resistors have been erased and their resultant is 6 kilo ohm resistor. So this is your 6 kilo ohm resistor. Okay, these are connected over here. Fine. Now this is simplified circuit. Then again, if you can have a look, this 6 kilo ohm resistor is in parallel with this 3 kilo ohm resistor. Why? Because on one side we have this node, both resistors are connected to this node. On the other side we have this node, both resistors are connected to this node. Again they are in parallel. Again their equivalent resistance will be the multiplication of both divided by the sum of both. So that is 18 divided by 9, which is 2 kilo ohm. Fine. So in place of these two resistors, I am going to connect a 2 kilo ohm resistor. So I am going to erase these two resistors and I am going to simply connect a 2 kilo ohm resistor over here. Fine. So let me connect a 2 kilo ohm resistor over here. So now I have a 2 kilo ohm resistor. Now if we can have a look, this 2 kilo ohm resistor and 4 kilo ohm resistor is in series. Fine. So now 4 kilo ohm plus 2 kilo ohm is equal to 6 kilo ohm. So now I am going to erase this stuff and simply I am going to write 6 kilo ohm resistor over here. So this is my 6 kilo ohm resistor. This is my 6 kilo ohm resistor. Fine. It's connected over here. Now again, if we can have a look, the 6 kilo ohm resistor on one side is connected to this node, on the other side it is connected to this node. Same is the case with this 6 kilo ohm resistor. So both are connected to this node on one side and both are connected to this node on one side because this all is shorted. So again there is a parallel combination of two, and when we take the parallel combination, the parallel combination will be equal to 6 multiplied by 6 divided by 6 plus 6, which is equal to 36 divided by 12, which comes out to be 3 kilo ohm. So the equivalent resistance of all those will be equal to, I am going to replace this by a 3 kilo ohm resistor. 3 kilo ohm resistor. So the equivalent resistance between A and B is equal to 3 kilo ohms. Now again we need to find the equivalent resistance between the terminals A and B. And we know that for parallel combination, the formula is this thing. For series combination, we simply need to add the resistors. Now again, we are going to start from the opposite side, which is this end. First of all, this 3 kilo ohm resistor is in series with this 6 kilo ohm resistor. So this series combination is going to get me 9 kilo ohm. So I have replaced 9 kilo ohm in place of this 3 kilo ohm and this 6 kilo ohm. And these resistors are as it is. So now we have simplified circuit over here. We can see over here, in place of this 3 kilo ohm and 6 kilo ohm resistor, I have the 9 kilo ohm resistor. Now if we can see, these 9 kilo ohm and this 18 kilo ohm resistors are in parallel. So for parallel, the formula is to multiply both and divide by the sum. 18 plus 9. So 18 multiplied by 9 divided by 18 plus 9. 18 multiplied by 9 is 162. And we have divided by 27. 18 plus 9 is 27. This comes out to be 6. That is 6 kilo ohm. So in place of these two resistors, I can connect a 6 kilo ohm resistor. I am going to remove these two resistors. Now I am going to connect a 6 kilo ohm resistor over here. 6 kilo ohm resistor over here. Fine. Now this 6 kilo ohm, this 6 kilo ohm and this 10 kilo ohm resistor are in series. So we have 6 plus 6 plus 10, that is equal to the 22 kilo ohm. So between the equivalent resistance between A and B is equal to 22 kilo ohm. Between A and B I have resistance of 22 kilo ohm, and that is our answer. Thank you. If you like my video, please subscribe to my channel.